Our company will lead biomaterials with the best technology and responsibility. 3D Materials. 3D Materials is an affiliated research institute of 극동중앙연구소 established in 1973. We have accumulated know-how in the field of fine chemical manufacturing for almost 50 years. We have many branches abroad, including the United States, Europe, and China. In 2016, we started the biomaterial business. Biomaterials can be used in the fields of 3D bioprinting, drug delivery system, and medical devices. Entering the IT and BT integration era, there has been an increasing interest in tissue regeneration and artificial organ manufacturing using 3D printing, and research on tissue engineering is actively being conducted. Tissue engineering is a biomedical engineering discipline that uses a combination of cells, materials, engineering methods. First, isolate cells from a patient's body and culture and proliferate them. Second, make scaffold through 3D printing, combining with cells, growth factors, and applying chemical stimulus. Third, incubate them to make tissue growth. Last, implant the artificial tissue back into the patient's body. 3D Materials develops materials used to manufacture scaffolds for tissue engineering. Product types include GELMA, PLGA, PCL, PLA, and PLCL. GELMA stands for gelatin methacrylate, the synthesis of gelatin with methacrylate and hydride. It can be dissolved in water and used at the required concentration, and due to the methacrylate functional group, it is cross-linked by light to form a gel. As for characteristics of GELMA, properties of it vary with temperature in aqueous solutions and are cross-linked by light. It is easy to mix biomolecules such as cells and growth factors in the temperature of 37 degrees Celsius, and is widely used in bio 3D printing because UV cross-linking can maintain permanent shape. Synthetic polymer is biocompatible and biodegradable materials that can be decomposed by chemical hydrolysis and enzymes in the body, including PCL, PLA, PLGA, and PLCL. As a copolymer, PLGA can control the rate of degradation and property by adjusting the ratio of lactide and glycolide, and the higher the glycolide ratio, the faster the degradation rate and the lower the solubility, especially when the ratio between lactide and glycolide is 1:1. It shows the time of degradation about 8 weeks. PLCL increases elongation as the ratio of caprolactone increases, and especially when the ratio of lactide to caprolactone is 1:1, it shows slight elasticity. Depending on the type of material, the rate of degradation varies from 2 weeks to more than 1 to 2 years. Depending on the field of application, the molecular weight and chemical composition of the material can be controlled to adjust the degradation time and properties. 3D Materials has strict quality control and sells proven products that have passed its own quality inspection standards for various items. In particular, GELMA from 3D Materials has excellent photo cross-linking and above 90% of high cell viability. Synthetic polymer can be customized for high purity and high quality products by adjusting molecular weight and composition. Taking a step further from developing materials for research and development, 3D Materials is preparing to introduce GMP facilities and certify FDA and KFDA to manufacture materials for artificial organs and medical materials. From now on, 3D Materials will contribute to society with passion, creative thinking, and the best quality. Global leader of biomaterials. 3D Materials.